Hello, my name is Josh Wurzbacher. I'm a regional sales manager for YCH Hops. We're here today to do a presentation on CO2 extract here in Yakima, Washington. I'm joined by some of the brightest minds in the industry, and we're going to go through a few slides to talk about some basic information and then open it up to questions and answers. But before we get started, we'll do some introductions.
Well, I'm Pat Jensen. I'm the Research and Development Director. So thanks, Josh, for calling me a bright mind. I think you're referring to me. Thank you so much.
I'm Rachel Goicoechea. I'm a brewer at Varietal Beer Company in Sunnyside, Washington.
I'm Joe Shanahan. I'm a regional sales manager for Yakima Chief. I'm stationed in Toledo, Ohio, so out here in Yakima to put this on.
And I'm Karl, Vanevenhoven, the Chief Operations Officer for Yakima Chief. I've been with the company for 24 years and built the first extract plant, and so happy to be here to talk a little bit about extract. So Josh, you want to tell us what extract is?
Yeah, let me get started. First, I wanted to say thank you to Rachel for joining us today. We really appreciate it.
Thanks for having me. Cheers.
Cheers.
If we can go ahead and get started with the slides. So Pat, let's start with you.
All right, so what is CO2 hop extract? So it's actually all given out in the name. So we made it easy. So it's an extract. That means there's an extraction process, and our chosen solvent is carbon dioxide, or CO2. So why choose something like CO2? Carbon dioxide is a pretty inert gas. It's not harsh, it's tasteless. It can act as an antibacterial or an antifungal. And it's actually non-polar. And if you see any of our survivable research webinars, you'd say, hey, wait a minute, almost every time you guys have told me that anything oxygen present is basically a polar molecule. That's not true with CO2, and it's because the oxygens are actually at opposite ends of the molecule. It makes the molecule linear. So because they're pulling in equal opposite directions, you get no net charge. So that's why it's a non-polar gas. Now, how do you actually extract with something like CO2? You can't, we all know that CO2 is actually a gas in the air. If we don't see it, it's not visible. So you have to put it in what we call a supercritical state. And how do we achieve a supercritical state? You have to apply pressure and temperature. And what is a supercritical state? That's kind of a liquid and gaseous phase of an atom or a molecule. So with CO2, and how you can kind of visualize that is you probably boiled water at least once in your life, and you see the steam or the vapor roll off boiling water, and that's kind of like a similar state as supercritical. And for CO2 to get into that state, you get to about 1100 psi and about 35 degrees Celsius, and that puts it in the state. So you have to have an extraction system that you can put this type of pressure on it. So what do we extract when we make hop extract? Would probably be a next follow-up question. What do you think?
What's the next slide?
Well, this is actually what extract looks like, and it is kind of an amber liquid. When you're done, it's not really a liquid, it's actually more of a paste at room temperature, but it's easy to liquefy when you hit about 120 to 130 Fahrenheit. And as we extract like the CO2, if you want to go ahead to the next slide there, what you extract, like I said, is non-polar, and everything that's non-polar happens to be mostly brewing ingredients. So such things as alpha and beta acids and essential oils. That's mainly what we're going to extract and what we're going to end up with in our final CO2 extract. There's a little bit of lipids and waxes that we get at the same time. And if you want to do some easy math for yourself to try to figure out how much weight you would determine on that, you could just take the alpha, beta, and oil, add that together, and that's about the extraction amount of mass that you'll actually extract out of a hop. Plus you add 2 to 3% for the lipids and fatty acids that you will also extract at the same time. So for most hops, that will equal to about 25% by weight is what you end up in your final extract.
I really like this chart because it shows that you leave behind, the 40% of cellulose in the water and the ashes, and it leaves you behind just like the pure essence of the hops, which will kind of lead into why we need to use CO2 extract in brewing. What's your next slide?
All right, so this is a basic flow diagram of the extraction facility. When you walk in the plant, it looks pretty complicated. This kind of boils it down to a more simplistic diagram. Basically, you're taking hop pellets, same pellet mills we use to make T90 pellets, same pellet mill we use to make cryo as well. But we load those into extraction vessels, and as Pat alluded to, that critical point is at 1100 psi. We actually operate at about 3 times that. So you're talking some pretty thick stainless steel, 6-inch thick vessel walls on the extractors, and we fit 2,000 pounds per extractor. And then we essentially just flow supercritical CO2 through it. Pat, he gives a good description of supercritical CO2. As we were driving up from Sunnyside, we were kind of talking about that. And after I got out of the car, I kind of thought of another way to describe it. And brewers all know what a brew kettle is, and they know boiling. You see the vapor. But let's say you had a really heavy-duty brew kettle, and you've got your level of wort in there, and as you're boiling, that level's going down. If you close that vessel, your pressure would be going up, of course, and then the density of that vapor phase is going to be increasing. And you add more heat because the boiling point's increasing as the pressure is increasing. And then when that level gets down to the very last drop, it's in that supercritical state. So the reason we use supercritical CO2 versus liquid CO2 is because it's much more efficient, because the CO2 fluid, I'm not going to call it liquid because it's not liquid anymore, but the fluid can flow through a solid matrix like a pellet, and then the things that are soluble in it, which is the alpha, the beta, and the hop oils, come through so that it has the solvation power of a liquid, but it has the low density of a gas. So that's why we use supercritical CO2. And so the process basically, if we did a single pass of CO2, we'd be wasting a lot of CO2. So a lot of the other heat exchangers you see there are to condense that CO2 gas, because we basically just vaporize the gas off, collect the extract. The gas then goes back, gets chilled and recondensed into a liquid. So we're constantly just recirculating the CO2 through the system.
I'm so glad we have you technical guys here today to explain all this for us. How much of the CO2 do we recapture?
The standard process that you see there, we recapture 98%. But under the sustainability side of the company with our corporate social responsibility, we added a CO2 recovery system. So we're recovering about 65% of that remaining 2% that we were losing. So we're over 99% now. And we're always looking at ways to recapture that last bit, but there's some parts of the process we just can't recover that CO2.
I remember my first time at the CO2 plant, it reminded me of working in a brewery. Everybody's in steel-toed boots and safety glasses with earplugs, and you got a strong team down there doing a lot of hard work.
Yeah, we have a lot of guys that have been there for a long time, people that we brought on, originally and trained up, who are now supervisors and managers running the plant. And so it's been a fun process to see it evolve, and I just kind of think back to, we'll get a little more into why CO2, but just for me personally, we're breathing it right now, we're drinking it right now, and you just simply let that pressure down and the CO2 gas is off, and then we recover that. So it's a nice process, and then you look at the quality side of it, and it has everything you want, but not a lot of the things you don't want, which I know you're going to get into, Josh.
Yeah, exactly. And I think brewers are very familiar with CO2. Every brewery has a CO2 chart in their office already, so this isn't, we're not using anything that breweries aren't familiar with already. I know that, previously, CO2 now is an industry standard, but previously they were using other compounds to extract, right? That might not have been as so good.
Yeah, to get into a little bit of the history, and when I started in the industry, I was actually working for Pfizer, who had a food science division. They had a CO2 plant in Nebraska, of all places. And before they had CO2, they were using hexane. Some of our competitors even use methylene chloride, which is some pretty nasty stuff. All that stuff fell out of favor, 80s, early 90s, because CO2 is just a far superior process, especially with those residuals that were there. But Pfizer sold their International Food Science Division, which brewing was part of, and the growers here in Yakima worked with Pfizer in the early days of Yakima Chief, and actually it wasn't even Yakima Chief yet, it was called Yakima Valley Hop Storage. And so when Pfizer sold, I left, and then that plant kind of was like up for sale. So the growers were going to buy that facility in Nebraska, and turned out somebody else wanted to buy it more than we did, and so, which was the best thing that could have ever happened to us, because we built one in our backyard next to our cold storage warehouses here in the Yakima Valley.
I love that story because, I know there was a lot of work being put into trying to buy that facility, and things didn't work out the way they wanted to, and they said, well, we'll just build our own.
Exactly, yeah.
Great cowboy spirit.
Yep.
Do it.
Cool, go to the next slide. So this is what kind of I call napkin math. I love just like little quick tidbits to kind of remember how to use these products. You know, when working with CO2 extract, there's a lot of benefits, and I think one of the biggest benefits is you're working with a quarter of the mass. So you're saving 75% in materials that, you know, that's reduced storage space, reduced shipping costs. This product's also very stable in the can. You can, in refrigerator, you can keep these cans for up to 5 years. On a shelf in the brew house, you can keep them for 3 years. A good way to remember, the T90 pellets will absorb a lot of beer. So 1 kilo of hops absorbs about 10 liters of beer. And if you look at any brewery of any size, 10 barrels, 100 barrels, you know, over the life of the brewery, that adds up to a ton of volume. And especially now when breweries are faced with all kinds of financial challenges in terms of freight and material costs, every penny you can save is a penny earned that you can pay back to your staff or reinvest back into the company. So CO2 extract is a great tool to be able to save more volume coming out of the hot side. As an example, you know, if you were using 10 pounds of Chinook in the kettle, whether that be the end of boil or the whirlpool, by switching to Chinook CO2 extract, you can save, you know, the 10 pounds, the 10 liters per pound by using just, you know, a 200 can and a 300 GMA can of CO2 extract. So a lot of impact in a little package. Go to the next slide. This is one of my favorite things to talk about is dosing method. I think brewers specifically are very creative when using these products. And what we like to say when using CO2 extract, whether it's in the kettle or the whirlpool, if you have a very vigorous boil, you can just heat these cans up and pour them directly in. There's some considerations to make there. If you have a direct fire kettle or an electric kettle, you want to prevent scorching. But going into the whirlpool, you can also just, you know, heat these cans up and mix them with a little hot liquor or a little hot wort, and then add it very slowly and get excellent solubility. But I've seen breweries do it so many different ways, you know, whether that's hanging a basket over the manway of the kettle and punching holes in the can and just throwing it in the basket, or leaving the punctured can in the grant, or throwing the can in the hop doser. Or Joe, you have any?
No, I mean those are probably the biggest ones. Some other one, yeah, I think another easy one. If you have a way to fish out the can, by all means, puncture and toss it in. I mean that can work. It will, the wort will flush it out. I know like a lot of larger facilities, they have hop dosers, so adding those in, pumping wort in, and then pumping it back into the kettle, and then going through the vigorous boil. That was pretty common. I've used that technique before. Smaller facilities, you can get really creative with adding it. It's not that complicated, and it doesn't have to be. Really the biggest thing that Josh touched on is just knowing, you know, your conversion to extract from a T90 to kind of substitute it out. But after that, it's kind of choose your own adventure with how you want to apply.
Rachel, how do you guys use it at Varietal?
So we typically warm it up in the grant during runoff, and then when you're ready to do your addition, often our additions are early on in the boil, so we just crack it open with a can opener, pour it in, grab a glove, kind of swish some wort into there, and, you know, safety first, but go forward, yeah.
Don't have your pants tucked into your boots when you're doing this.
Exactly, always over the boots,
Yeah.
always.
Yeah, the kitchen grade can opener, those work great.
Yeah, absolutely.
And, but one of my favorites was when I was down visiting Jeremy at Lagunitas. He had someone made a baseball bat that they then attached a stainless steel pipe. They cut at an angle, and it was like a sword.
We did that until at least at the Chicago facility I was at, we did that until we were like, okay, this might be a safety hazard. So we just got a can opener, just popped 3 slots into, and then threw the hot doser. But yes, we have time for it.
Gotta get adventurous.
Yeah, exactly.
You know, and I worked on a couple different size systems with CO2 extract, and what we would do is just leave the can right on top of the kettle. As you're coming to a boil, that would heat the can up plenty. Open it up, pour it in a pitcher, add some hot water. We do recommend that you dissolve this in a little bit of hot water just to make sure that, again, if you have an electric kettle or a direct fire, it doesn't sink right to the bottom and scorch. But don't let that scare you. This is a very easy product to work with. It's extremely consistent. I would much rather carry a couple cans up the brewhouse stairs than a couple 44-pound boxes.
Yeah.
No joke.
And I think Josh kind of touched on it too, and I'll just kind of reiterate too, like the cost effectiveness of this stuff is huge. I mean, cold storage is always premium real estate in a brewery, at least everywhere I've worked, so the ability to store this ambient or store it in cold as you choose is huge. I mean, that just opens up more room. Shipping a quarter of the mass, I mean, that's also wildly, save you a ton of money that way.
Especially now.
Yeah, especially more ever now. So I mean, And it's also something where I've kind of always felt like it's a product that can go into more than just IPAs. I mean, don't feel like you need to use this in an IPA. Use it in a light lager, use it in a stout. Wherever IBUs are needed, you can apply this product. So I feel like don't hinder your creative ability to use this. So.
Yeah, and if it hits on the cost side, it hits on the sustainability side too,
Exactly.
which checks that extra box for me as well. Yeah. And if you think about your beer yield increases, that means you can either make more beer, which a lot of breweries need, but you might be at a stable volume, and if you're making more beer with less inputs, then that means you're also on the sustainability front too, because you don't need to brew as much, so there's less electricity and gas that goes into making a batch of beer. So
I mean, that's another great point. Even with, I think some people overlook that, using CO2 extract in kettle, you might not foul out the walls of your kettle or your whirlpool as much, so you require less cleaning, less chemicals, less plant matter going down the drain, so you're not getting hit for BODs. There's a lot of benefits to using CO2 extract.
Rachel, have you had any obscure notes to add that we've missed that you're noticing?
Well, I wanted to touch on the turbulent boil and scorching issue. We're direct fire. We have a very turbulent boil, and we don't have any experienced issues of scorching. So I feel pretty safe on that, especially if you're, not steam, but you're doing direct fire. We don't have a ton of issue. We do have a little bit of a scorch right by the direct fire, but it's definitely not anything that we're trying really hard to battle. It's not been an issue. Aside from that, doing the addition early on, that sideline benefit of reduced kettle foam, helping you manage that hot break, less danger of boil over, definitely not gone completely, but it's a lot safer. And then you get those great smells all the way through too, which is so great. And again, the reduced wort loss is so nice, and it creates just that nice, clean, bitter backbone that you can build the rest of your hop profile off of and get that reduced vegetal flavor quotient of it and fewer polyphenols, just a lot cleaner.
Yeah, absolutely. I love that reduced kettle foam formation is something that I like to tell brewers, kettle boilovers are one of the most dangerous things that can happen in a brewery, and you're reducing risk to your brewery. I mean, it's just another great benefit of using this product.
Absolutely. It's not fun to clean up either if it happens, so.
Don't tuck your pants in your boots, guys.
Yeah.
You go to the next slide. So we didn't want to spend a whole lot of time on calculations. We didn't want to do a live demonstration, but we have these great calculators on our website that are very intuitive. If you're considering changing a recipe from T90 to extract, we have some great calculators that can help you figure out very specific weights to use. No calculator is perfect. There are a lot of factors involved. All brew houses are different, operations are different. So we always say that some trial and error is always required, but these calculators will get you very close. I've sat down with breweries who were interested in using CO2 extract, took their existing recipe, was able to punch in the numbers very quickly and give them out amount of GMA that they needed, got that order to them. I had a trial batch done in 7 days, and they love the product. So this is not something that's complicated or needs a lot of extra thought. It's very easy to use.
It's right on our website. I mean, it's plug and play. I mean, even if you just want to kind of get a check on it, I mean, by all means, go to our website or reach out to Josh or myself. I'd be happy to send you the link to it. Plug and play, super easy, give it a go. I mean, low risk, high reward.
Next slide.
all right, well, today's a pretty exciting day, actually. Monday, our logo got painted on the building there, but we're building a new extract plant. So yeah, built the original one, started in '98, and started building it, started up in '99, and today we are turning it on. So we're doing our first, the CO2's in the system. No hops in the system yet. It's kind of like starting up a brewery with just water. Just test everything out. So yeah, we're beginning our site acceptance test. So it's a pretty exciting day down in Sunnyside. Wish I was there. But it's good to be here talking about it. So, and we're building a new facility because we were just, demand was outpacing our capacity. So having the second facility will give us more agility to fill orders, multiple orders at the same time. One fun thing with this, we did add, if you looked back at that original design, we added something a little bit different. I don't want to say too much about it other than Pat's been doing some really cool stuff with the R&D team and the lab, and we've got, we think we have a pretty new and exciting product that's going to be coming out of the new facility. So I don't know if you want to talk about that a little bit.
Pat, can you share any teasers?
Well, it's more aroma-based, so instead of just being like alpha-based, like extract has been primarily used in the past, we are going after aroma-based now. And had some good trials with some partner breweries already, so.
And you can try out with it.
And we've had success. And yeah, CO2 Hop Extract, I think we're bringing it up later, that you can't, really has not been ever used on the dry hop application, but this stuff seems to be flowable enough to make that a possibility.
It's exciting. Love new products.
Yeah, absolutely. And the other thing this facility will afford the opportunity too is we know there's more opportunities out there because we were at capacity, so we'll now be able to meet those demands that are out there in the market. And you know, when I started long ago and craft was a fraction of the size it is today, hop extract was kind of viewed as this, ooh, only the big guys use it. And I just remember, it's been a while since I've looked at it, but you know, you open up, you know, the Zymergy magazine, they always have their top 50 voted on by home brewers. And if you look at the beers on that list, a lot of those have extract in them. And you can really fine tune recipes, you can control your IBUs well, you can use it late. The beauty of the product is those soluble components, the alpha, beta, the hop oils, you're getting what you want out of the hop with CO2, which is already in the beer. So it's not a product that craft brewers should shy away from just as, oh, it's industrial beer, it's yellow beer. You can use it in any beer style. Yep. So it really affords all those opportunities. So,
with the extra capacity for the new plant, if a brewery partner has some excess hops that they'd like to extract, is there possibilities there?
So we call it tolling in the industry. And tolling simply means we don't own the hops, somebody else does, and they pay us. It's kind of like contract brewing. So we've in the past done a lot of this where a brewer's over-contracted. You know, there's a shelf life on those hops of 3 years. You know, they might be in year 2 and they're over-contracted the next year, they see a train wreck coming. So this is a good way to help out those brewers that have, and it's usually bigger brewers. If someone comes and says, hey, I got 44 pounds, can you extract it for me? No. But
2,000 pound minimum.
But you know, if you got 10,000 pounds, we're starting to get into that volume, especially if it's a variety we're already running, we can just tag it on to another run. So it is a way to extend your shelf life because extract has that 5-year shelf life at cold storage. We say 3 years at ambient, but in reality, I have a jar on my desk from 1999 and the first pack out we ever did. It's been poked at, sniffed, it's been on my desk, opened in oxygen, and every now and then I analyze it, it's lost. I mean, it used to be like 57% alpha, now it's 55. I mean,
That's incredible.
Now, on the aroma side, I wouldn't use it, but point being, on the alpha side, it's extremely stable. And on the aroma side, it's got that 5-year shelf life of cold storage, no problem. So it's got those advantages too. So yeah, tolling with the new facility, we've got some additional tolling capacities.
Great option for breweries.
Yep.
I think a fun tidbit to add to that, Carl, because it's 55% now, is that they've changed the analytical standard for hops 4 times since you've extracted it. So it actually might still be to the original analytical standard.
This is true. You bring up some, not to bore you guys with old man stuff, but when I started, we had 3 different methods of analysis just for HPLC. So in our ERP, we had to have, back in then it was called EBC2, EBC3, I think, and then they came out with ICE1, and now those standards have, but yeah, we used to actually have to keep inventories of the different standards just by the method of HPLC. Today it's a little easier, we have 3 different ways of analyzing hops, but which we have to, so our lot lookup tool has all 3 of them. If we don't always test MEBAC, but we have UV, HPLC on pretty much everything. So
that's why we moved to the QR code on our products now, right?
Yeah, because okay, which customer ordered which and what alpha goes on the package. And with extract, we still have that problem. But for all just standard extract off the shelf, we use the UV method because that's what we're used to using in the craft industry.
Josh, we have some questions for you guys.
Go ahead.
We've got one in the chat. How much hops do you extract in one run?
Carl?
In one run, that extraction vessel I was talking about, that fits 2,000 pounds. And a good way to kind of equate that is should be yielding better than that on the farm, but if you have a 10 bale yield on a farm, you're basically fitting an acre of hops into one vessel. And of that, we run usually about 12 vessels per day. And we run 24/7. We shut down for 2 to 3 weeks in the summer to do calibration on instrumentation, send out relief valves to be recertified. But for the most part, we're running 24/7 year round, which is also why we built the new facility, because it's a lot of work.
Continuous work, so you don't have to stop, shut down, and have delays.
Yeah, the only major shutdowns we do is that summer cleanup shutdown for maintenance, and then we do organic as well. So we do have organic extract available. So, but we have to do a complete clean out of that, and it takes about 5 days. So we have to tear everything apart and do a CIP loop and everything, and then we have swabs where we go back and test everything to make sure there's nothing left in there. We also would do a similar clean out for a crop change because we've extracted hemp and some other nutraceuticals as well.
Interesting.
Yep.
All right, we have some more frequently asked questions. Why should a brewer use CO2 hop extract?
You know, we talked about a few of these points, but the reality is the yield savings out of the hot side is the number one, the primary reason you would use CO2 extract. If you can use a quarter of the mass and have zero vegetal wort absorption, you're just going to get more yield into the tank, especially for breweries who don't actively DE or centrifuge filter. Getting the most beer in the bright tank possible. I mean, on a 10-barrel system, you know, you could be looking at 7 to 8 cases, you know, over the week, over the month, over the year, over the life of the brewery. That could add up to a ton of volume.
And then pair that, like we talked about too, with the intangible factors like cold storage, ambient storage, shipping, shelf life, I mean, things like that, that just adds to the overall value of using extract.
As a brewer who works in a place that had serious issues with effluent, you know, having the reduced vegetal matter going down the drain, it's just, you know, it was huge for us, which was the main reason we went to CO2 extract.
Absolutely.
It's a very clean, consistent product too. You know exactly what you're getting, you know exactly what you're going to yield out of it in terms of alphas, and it's just a nice clean bitterness that you can impart without having to introduce all of these other factors into it. It's really nice.
Yeah, and Josh, one other thing you guys had mentioned earlier is that just throwing a little bit of pellets too in the kettle. Can you explain why you would, rather than use 100% extract for an addition, why you would add some pellets?
The easiest form is if your recipe is like 34 IBUs, just get the other 4 out of pellets rather than cracking an additional can and trying to calibrate that. The more, I guess the more technical form is, I mean, what would you say, Josh? It's kind of...
you know, having a little bit of pellets in the kettle during the boil gives some nucleation points to help break up that extract and help it solubilize even faster, especially if you're looking at, you know, end of boil additions. Just to give you a few touch points in there to help stir it up even better.
Yeah, and even if you have your IBUs dialed in perfectly, just take a handful. And just a little bit of that plant matter. I don't know what it does. The nucleation sites, I think, is the best explanation, but there's something magical that happens. Also, boom, your utilization goes way up.
Yep.
Well, chemicals, they always like, they're not inclusive, they're exclusive, so they like similar things, and having that plant matter there just gives the extract something to attach to, which allows the water now to attach to both and release. So that's kind of the helper.
Yeah, and with Joe's point especially, you know, we talk about, breweries ask me all the time if they can have an open can of extract, and they weigh out what they need and put the rest back. You absolutely can. What we used to do is if we used a partial can, would be wrap it in a little bit of plastic and then some aluminum foil, go right back on the coldest part of the cooler, and you can bring it out the next day or the next week, and it's totally fine.
There's actual lids you could actually buy.
Oh yeah?
To your local restaurant store, that little plastic lids that you could probably buy at your restaurant.
Well, I got some
store.
swag ideas for our marketing department.
That would fit that can that you can just put back on.
What varieties are available in CO2 hop extract?
So I'm going to repeat the question because I don't know if they can hear you. So what varieties are available in hop extract?
You know, one thing I don't think we talked about enough is that CO2 extract is variety specific. For bittering or aroma, you can typically get any variety that you need. Simcoe for aroma, Mosaic for aroma, and CTZ for bittering. We have tons of varieties available, including Idaho 7, which if you're familiar with our survivable compounds material, Idaho 7 is very high in survivable compounds. I think it's the perfect end of boil or early whirlpool edition aroma hop CO2 extract you can use. What varieties do you guys use at the brewery?
We use Chinook a lot and Warrior. In the past, we've used Pato and Mosaic. So we've kind of stuck to those four, but yeah.
Is this Chinook?
This is Chinook.
Excellent.
We've gone through some trials where we've done Warrior, we've done Pato, we've done Mosaic, and we kind of settled on Chinook because we like that clean, kind of bright, grapefruity bitterness that it imparts. And yeah, so you definitely can tell, even early additions, it's going through everything, but you can still kind of hold on to that varietal specific flavor compound, which is really cool. And yeah, we could definitely tell the difference, and this is Chinook that we landed on.
And Rachel, it's so nice to be back in the Northwest and have a Northwest style IPA.
Yeah, welcome back.
Been missing that after living in Europe the last almost 3 years. It's good timing to be over there now because there's IPAs everywhere, and I love
Sure.
Belgian beer, so that was nice too.
Yeah.
But man, everything's hazy over there, and I miss my Northwest IPAs. So.
Balance of bitterness, fully filtered.
I'm glad we can
Good to
provide
be
it.
home for a lot of reasons.
You like brewer's beer. One more touch point on the varietal specific. I work with a brewery that a lot of breweries ask me all the time, like, we're barely bittering anymore. Most of our beers are juicy IPAs with low IBUs. I work with a brewery in Mid-Atlantic, very prestigious brewery, working on 2 different size systems, and they were using CO2 extract in the whirlpool and dry hopping with cryo as a trial beer for one of their flagship brands. And I called him and I was like, how'd the beer turn out? He's like, the beer tasted amazing, but we got 30 cases more beer out of the fermenter, which they were very, very happy about.
That's actually a great point too, because if you use if you use the calculator and you want to make a whirlpool edition of Idaho 7, your IBUs may not scale up as high as you think they do. If it's touched down to 180 or 185, whatever the lowest temp recommendation is, you're not necessarily going to carry over some astronomically high IBU into that beer. So you can still make a great hazy without having to balance it out with bitterness. You can still keep that super sweet haze bomb that you're looking for. So.
Keep the aroma, very little isomerization.
Exactly.
Well, to add to that point, to get a little more technical to you, there's actually compounds called humulinones that are always present in pellets and hops. Those are not present in the extract, so your amount of alpha is 100%. That's all you're getting. You're not getting any of those extra bittering components at all. So it's easier to calculate the exact amount.
That's really interesting. Perceived bitterness.
And in the whirlpool edition, that's where you would actually absorb more humulinones would become more soluble. In that edition, it's probably not so much isomerization. Even if you're adding pellets at that time, it's all about those humulinones at that time.
What is the minimum temperature in the whirlpool you'd recommend adding CO2 extract?
I go with people who actually do it all the time. I like extract to be flowable if you're doing it on the whirlpool side. So like you said, if you can heat it before you pour it in, that just gives you that idea you could turn. I'd actually like you to have some agitation at that time, so you just make sure you're getting it throughout.
Maybe even pouring in the bucket with some wort and giving it a
sure
stir,
you give it a
and then
little
adding
bit.
it slowly so you get good solubility.
Yep.
Depends on the brew house, of course, too.
Yeah, a lot of factors.
But yeah, I proceed with caution a little bit maybe there, but 'cause,
Yeah.
you want to make sure it's important that you get it dissolved.
Yeah. Well, that's why I asked the lower temperature. A lot of breweries are doing cool pools now and chilling the whirlpool to preserve as much aroma as possible. I think I've heard that 185 is the minimum temperature you might want to add these extracts. Have you ever heard that?
I think 185 is a good low point. If you want to go lower, like I said, proceed with caution. It's there's a heat exchanger that maybe you could gum up a little bit, and especially if you have some plant matter in there too.
Right.
Trial and error.
There's a lot of factors. Breweries all the time ask me about IBU calculations, and I can give you a close answer, but it won't be perfect because there's so many things that are different about each individual brew house. Even the brewer themselves and the way they design recipes can be different.
Yeah, and like in that, because we're dealing with extract all the time, and it's when you spill it, it's hard to clean up. And we have a caustic product that we use. It's called Alchemax from a company called CH2O, and it knocks extract out. It cleans it really well. That's what we use in our CIP loops. So something like that. It's I believe it's potassium hydroxide base, but they've got some other kind of magical surfactants and detergents in there that, but it rinses clean, and it's So you're going to want to have something like that just in the brewery anyway. So
I can
you
attest
probably
to
already
that.
have it.
Yeah, that's what we use, and yeah, I've
okay.
spilled some kind of on the kettle as you're getting it in there, and it's
And it's cooked on, and
yeah,
scrub it maybe a little bit.
The Alchemax works really well to get it off. So it can be very, very sticky.
How will this product save a brewery money?
The way this product will save a brewery money, we talked about it a lot, but I think it's worth repeating. The yield savings from the hot side are the single most important point of using CO2 extract. But then again, it's like reduced cleaning, reduced vegetable matter down the drain, reduced shipping, reduced storage requirements. I bet if we sat down for another hour, we could probably tease out a few more cost
yeah, I was
savings.
going to say more sellable product is huge. I mean, that's just massive, I think, so.
Yeah, shelf life stability.
Yeah, and I'll kind of reiterate too, it's not like we're using any funky chemicals or anything, it's CO2. So that mystique of it's just a big brewery product, to me, it's took a long time in the beginning to kind of bust that myth, but I feel like there's been a lot of work done on that, but there's a lot of new breweries, opening every day, and so this is a product that, some may not even think about that. 150 GMA10, there is a little bit of a barrier for a nano brewery, then you're going to have to be using partial tins. But
Well, we have a 3-barrel brewery here, and I think he uses CO2 extract in almost all his recipes.
yeah, I mean, it
it's
can be done.
absolutely,
yeah.
It's nice if 150 GMA10 is generally the smallest 10 that we offer in most varieties. So that gives you, what's the calculation on a 15-barrel brew house, or 30, you did a 30-barrel brew house?
150 GMA on a 10-barrel brew house is 30 IBUs.
Yeah. So if you're making an IPA and you want to make it 60 IBUs, you can use 2 cans, or you can use 1 can and then pellets, blah, blah, blah. But always recommend using 1 can. And so.
Yeah, I love that 1 can, 10 barrels, 30 IBUs. It's,
Yeah.
just in my head, it's easy to sit down with the brewer and
Yeah.
scale it down.
Yeah.
Is this a sustainable product?
Yeah, we touched on some of that before. Because of the yield gains, it definitely checks the sustainability box there. We're recovering 99% of our CO2. We're actually looking into creating our own CO2. I wish we had a big brewery next door, but that's something else I'll throw there too. Is big breweries, you should be recapturing your CO2 and reusing it, and that technology is improving so it can hit smaller breweries. I mean, not the size of Varietal, but
There's
it's
a 30-barrel
regional.
system by my house that now has a CO2 capture.
30 barrel, really?
Wow.
They're really
Wow.
small systems, like the size of a small closet.
Wow, that's impressive.
On
I hadn't
on a
heard
skid,
that.
they can wheel it around.
That is so cool. Maybe we need to buy one of those. Our recovery system is quite huge. It would take up this room, and it's 3 times as tall, but we are looking at making our own CO2. So there's a lot of ag waste in the valley here. The Yakima Valley, of course, it doesn't just grow hops, but it grows just about everything except citra. And so we're looking at, we actually have a grant, and we're doing research on this. So we're just looking at doing either digestion or some other type of, composting type degradation that off-gasses CO2. It also off-gasses natural gas, so there would be a renewable natural gas supply as well. So we could run our boilers, but it's there's a lot of the technologies out there, but it's not proven exactly for what we need right now. But like I said, we have some grant money. We're funding the research as well, and so someday we hope to be completely sustainable and self-sufficient on making our own CO2.
Yeah, not just for our company, but for the Yakima Valley in general. Sustainability is everything. Protecting our water, protecting our land, and making sure that this industry will be productive for generations in this area.
That's part of our values. We're a grow our own company, and most of the farms are 5 generations plus, and that's kind of why Yakima Chief exists. Those are our original values and foundation. So yeah, we look at a lot of things from that sustainability standpoint.
Question from the chat. Suggestions on how to measure a partial dose from a can?
Probably, I would say probably based
By
on
weight.
weight. Yeah, probably based on weight would be my recommendation. So if you have a 150 GMA10 grams of alpha, I mean, probably just weigh it out, see, calculate it in via the calculator, and you should be all set.
Yeah, I even use extract when I homebrew. I just take a
Teaspoon.
measuring cup on my little scale, and then yeah, just and the wort. And any brewing calculator, you just create a new variety, right? So normally you're going to have your normal T90 pellet varieties in the calculator, but then you just add extract, and okay, it's look at the can, it's 57.6% alpha, and you can create a new variety or whatever your software is. You just enter the alpha, and then so yeah, weight times alpha, it's the same calculation. When you get to the whirlpool, it's the same with pellets. What is your utilization there? So depending on what software you're using or how you're doing that, you would kind of do it the same way as pellets. Just your alphas, 4 times as much as it was if it was a T90 pellet. Yep.
It's been said that the extract takes something away from the art of brewing. What are your thoughts, or how would you respond to this?
Rachel, what would you say?
Active brewer.
It's a great question. I think if anything, it's a different style of product that allows you to be more flexible, and it allows you to harness the magic of hops in different ways. And I think that how you use it, so when you're adding, how much you're adding, how it plays into your recipe with all the different hop additions and dry hop and everything, is where the art of brewing really exists. I don't necessarily think of this as a shortcut or anything, more as a tool to accomplish something that you couldn't necessarily accomplish before. And having the sideline benefits of, the less wort absorption and the anti-foaming agent properties and all of that just allows you to kind of utilize that flexibility a little bit more. And I don't think it ruins the art, because the art is in how you're approaching the overall process and treating the beer overall rather than just this one product. There's so much that goes into it.
I also just feel like, we're not changing hops. Hops are still hops. We're just repacking them in a form that gives you what brewers are looking for. So at the end of the day, we're not changing, it's not GMO or anything like that. It is still hops, just extracted. It's concentrate.
Pellets are processed. CO2 extract is just one more
Another
step
process.
in the process.
Yeah, it's
Exactly.
I was going to say, you could make the same argument about T90 pellets.
yeah.
Why aren't you using whole cones every time?
Why are you using what hops?
Yeah, leaf hops is down to about 1% of our sales, so we all know why, because it's more efficient. It's on many levels. It stores longer, and extract is just one more step beyond T90, which cryo is one more step beyond T90 as well. So it's just the evolution of technology and advancements and improvement, sustainability, and et cetera. So it's so that's how we would answer that, I guess. Anything else to add?
Well, as a chemist, I'm basically soulless. I don't believe in it. So I try to turn it all into science and try to get you maximum efficiency per month. And that's not to take away what you guys discussed. No, I don't really think you're changing anything about the art of brewing. You're trying to outguess what you're doing, and by reducing your guessing parameters is what you're doing.
Yeah.
So it is actually still an art. There's still some guesswork to do. You're still going to add yeast. And that's why they came up with that term biotransformation, because they're saying, stuff happens when I add yeast.
We'll see how it turns out.
Yeah, what did we learn today? So our mad scientist, hop chemist, is soulless. And what happens on biotransformation?
What else? You got nothing else from all the technical side?
What is the quality of the pellets YCH is extracting?
Want me to take that one?
Yes, please, Karl.
All right.
Karl, what are your thoughts on that?
Well, quality it's everything we do. And, I talk to growers about this. I'm like, there's very, very few things I can do to improve quality. And that's why we also take the quality program to the farm. And we have really, strict requirements on the growers that other companies don't. So it starts at the farm. Once we get it in our doors, I can only maintain it, I can't improve it. The only ways I can improve quality is, say, cryo, for example, and it's not necessarily improving quality, but it's maybe taking something away that you don't want. So in cryo, we're removing the bract fraction, a portion of it, and concentrating the things that brewers want. Now, that bract fraction is actually quite attractive too. You just might want a different spot for a different style of beer. For extract, again, we're just removing a part of it, and so the spent material, what we call spents, is just cattle feed. So we pelletize that and sell it into the cattle industry, much like a brewer does with their spent grain. Everything we do is about quality, so quality goes into that, and that's the beautiful thing is, and it's also garbage in, garbage out. So if you use garbage quality pellets to go into extraction, you're going to get something that's I definitely wouldn't want to brew with. You can still get the bittering qualities, but I find I'm extremely sensitive to it, probably because I've been around it so long. Like Rachel, since you're using extract, I don't know if you've noticed this, but you drop some extract on the floor and don't clean it, and it sits there and oxidizes, and then you just get this oxidized hop smell in the brewery that's just sweaty feet, it's just kind of gross.
Cheesy and weird. Yeah.
So extraction can clean some of that out, but if you were to take 10-year-old hops and extract them, they're still going to be gross. There's also something within the degraded alpha, I don't know, Pat, if you know what it is, but as alpha degrades, whatever the degraded components are, they block the extraction of the remaining alpha. So it's not even worth extracting like super old hops because you just can't get anything out of it anyway. And I think the molecule, I don't know if it's not soluble anymore.
Going back to the nucleization point, if you don't have something for it to help bind to, it's going to stay with what it likes, and that alpha is going to like molecules that are more similar to it rather than go with the CO2. So that kind of blocks it. So then you have to go extreme on your pressure, and then you really make a messy extract.
I think it's a great question because I've had brewers ask before. They think that we're just extracting the pellets that we couldn't sell. But that's not true at all. We maintain high standards for everything that we do, and we extract high quality pellets to make high quality extract.
Yeah, exactly.
What future innovations are possible with CO2 hop extract?
Pat kind of touched on it with the aroma.
Karl already brought up the fact with the new extraction facility that we're making that it allows us to like take separate components and separate. So with, like I said, we have this aroma addition product that's on the verge of being released. It's getting really close to being happy with it. And so then you're like, instead of like, we've been talking 4-to-1 on replacement, you're talking 50-to-1 on the aroma addition. So you're like, that's pretty extreme. So
some real savings in shipping.
Imagine how much the savings is and how much you could get in a little bottle.
Yeah.
How many barrels you're going to make on that level.
Yeah, and that's not a pure hop oil product that we're working on currently. We have been working on that as well, and I kind of refer to it as a unicorn. I mean, there are hop oils. There's a lot of them out there available in the industry, but when you go through a process to remove oil, it typically involves heat.
Lots of it.
And the hop oil products, we just don't want to put our name on a hop oil product that we found so far because it doesn't meet the quality that we're looking for. It's not something that we would say you can use as a dry hop replacement or even a partial replacement. I mean, you can, but it's just not the quality we're looking for yet. So Pat and his team are also working on that. And there's a number of different ways to do that, but having extract as a feedstock is one way to do that because it has very clean hop oil properties to it because it's a gentle process. I guess we didn't talk about that. We extract at gentle temperatures, so the oils aren't degraded. So it is a good feedstock to try to make a hop oil product. So someday maybe we can find that unicorn, but we are looking at that as well. But the product that Pat referred to earlier is something that, I don't want to let the cat out of the bag, but it's not a pure hop oil product. It comes out of extraction, but it is soluble and readily dosable into dry hopping, into the fermenter.
So you heard it here, some new exciting products.
It's something like, well, to add on to some of those hop oil products that are actually derived from hop or CO2 hop extract, actually go through a lot of processing that involves acids and bases, so you end up hitting these oils with extreme caustics and extreme acids. And that just kind of changes the profile altogether. So to say in the end that you still have the varietal type, you're really stretching the truth of it.
Mm-hmm. Yeah. And to reiterate, extraction is CO2 only.
Yeah.
So.
Someone in the chat said, let's talk about the opposite side of the coin. What happens to the plant matter? Can it be used to produce other styles of beer?
So what we referred to as the spent hops, well, Pat, I'll let you tackle that one.
Well, I don't know how much I could really say, but there are companies that actually brew with spent hops, and they try to release what's still bound in the spent hops, which would be something like a glycosidically bonded material such as triennial or linalool. And some big name brewers do use this and buy this product for that purpose.
And
give their
or
names out.
even do some additional processing to make an extremely light, stable product. There's also a lot of, it's about 18% protein. That's why it goes into cattle feed. So we've looked at, okay, is there a way to make, health protein shakes, blah, blah, blah. But it's not something we put a lot of research and effort into because our core competency is hops for brewing. But we do have a new person who's on the team that's looking at a non-brewing use of hops that recently came on board a few months ago. So it's something we're dabbling with and looking into because, yeah, we'd love to find an outlet other than just cattle feed.
And I'll just add, there's more extractable materials actually in that spent hops that's actually been used for anti-cancer treatments and just health benefits there that we haven't taken advantage of at this time. So, kind of polyphenol base, which is actually left in that spent hop material. So.
You were talking about you maybe in the future looking at getting like an aerobic digester to help produce CO2. Could you use those spent hops for that as well?
Yeah. Yeah, we're primarily looking at the farm waste. So when you pick hops, you've got this vine and leaves and everything else. So that's a big waste part that there's not a good outlet for, at least with the spent hops. It's going into cattle feed, but we've also looked at using those as a biofuel pellet, using a gasifier. So there's a number of different technologies and things we're looking at right there to really, use every piece of the supply chain, which, yeah, cattle feed is being used, but it's not the ideal, especially when there's all these interesting properties that are still in there that may not really have brewing use. The glycosides are interesting, but the rest of it, there's not a lot of brewing use to it. Although, I mean, we actually do have one other patent on a way of using the spent material actually in the mash and providing some of that polyphenol, and it helps reduce oxidation. So, yeah, we're looking into lots of things.
That's why I get so excited talking about this topic because it goes really far. It's not just about brewing applications. Like, the science behind it is very interesting.
Yeah.
What are the benefits of supercritical extraction?
Are there any negative sides to maybe doing like a subcritical CO2 extraction?
When I worked at Pfizer, we did liquid or subcritical extraction. So our current extract plant has 3 extraction vessels of 2,000 liters each, so 6,000 liters of extraction capacity. That plant had 7 extractors that were 6,000 liters, so 42,000 liters. So it's huge. And it was the same annual capacity because the solubility using liquid CO2 is so low. And you get the same product with supercritical versus liquid. You do get a little bit more of the, if you looked at that pie chart, you might get a fraction of a percent more of the lipids and waxes, but it's negligible. And we actually looked at that when we built the plant 20 plus years ago, and the cost to build a facility is like 4 times, and there's no brewing advantage of doing it. So. And we can run it liquid if someone wants to pay 4 times as much. We can do it. We haven't had anybody knocking on that door. So
That's like a 10-hour extraction versus 4-hour.
At least. Yeah. We actually ran 24 to 36-hour extractions, but that was on 6,000 pounds.
If I was on that staff at that time, I would have told you guys that's silly. Why are we doing that?
If I was a brewer, I'd say we need to turn this faster.
Yeah, exactly.
Okay, well, we're going to wrap it up there. Thank you guys for watching. I want to thank all of our panelists today for providing a lot of great information. I had a lot of fun talking about this topic.
Yeah.
If you have any questions, you can reach us at the Brewing Help Desk at brewinghelp@yakimachief.com. You can find that also on our website, and Joe and I are also always available. Please reach out to us directly. We'd be happy to help you with any questions. And again, thank all my panelists today. Really appreciate it.
Thank you, Josh.
Thanks for having
Glad
us.
to be here.
You're all.
Cheers. Out of beer, we're
Yeah,
done.
cheers.